After a journey of billions of kilometers from one star system to another, a visitor in our solar system is not moving exactly as we expected, and this has captured the attention of observatories around the world. The object we're referring to is an interstellar comet known as 3I Atlas. The term interstellar means it doesn't belong to our solar system. It is a cosmic traveler that broke away from the orbit of another star. Since its identification as an interstellar visitor in mid-2025, 3I Atlas has moved steadily through the inner solar system. On October 29th, it passed its closest point to the Sun. Around that time, astronomers recorded a sudden surge in its brightness. This indicated intense outgassing, a process where previously shadowed ices vaporize upon contact with sunlight. Spectral data showed brief jets of water vapor, carbon compounds, and trace metals venting into space. While these phenomena are normal for comets, what caught scientists' attention wasn't the events themselves, but the result they produced. Gases erupting from a comet give it a small push, like a tiny rocket engine. This is a non-gravitational movement, and it's an expected phenomenon. However, the acceleration pattern of 3I Atlas was not fully consistent with models of uniform outgassing. Small, irregular shifts were observed in the object's motion. While these deviations are not proof of anything artificial, they provide valuable insight into how interstellar material behaves under solar radiation. This erratic movement has prompted researchers to refine the comet's orbit and rotation models. It's now thought that the object's nucleus is not uniform, with some regions being more active than others. This anomaly has led some scientists, including a Harvard astrophysicist, to renew calls for transparency. These scientists argue that the physics behind such motion should be investigated without bias. The goal is not to imply artificial design, but to show that understanding unexpected forces can reveal new natural processes. Meanwhile, despite the ongoing US government shutdown, teams at NASA's Goddard Space Flight Center and the Jet Propulsion Laboratory are continuing essential tracking operations. Congresswoman Anna Paulina Luna has formally requested that new images and data be released for public analysis. This shows that discoveries in space now have not only scientific, but also political resonance. What makes 3I Atlas special isn't just that it's rare, it's that it serves as a living laboratory for testing theories about how planetary systems exchange material. Spectroscopic measurements indicate that its ice and dust share similarities with comets from our own Kuiper belt. However, some chemical ratios, particularly carbon to oxygen and nitrogen-bearing compounds, appear distinctly different. These differences suggest that 3I Atlas likely formed in a colder, more distant protoplanetary disk, perhaps around a small, faint star. Understanding these details could refine our models of how water and organic molecules migrate across the galaxy. If 3I Atlas contains isotopic ratios outside of our solar system's norms, it would confirm that the chemical diversity between stellar systems is broader than previously thought. The most significant factor separating this event from the 2017 visit of Oumuamua is the level of international cooperation. More than a dozen research institutions are sharing real-time observations through the International Asteroid Warning Network. The European Space Agency and universities around the globe have joined this network. This global campaign brings together professional and amateur astronomers to collect data across multiple wavelengths, aiming to map gas emissions, dust density, and compositional shifts as the comet cools. 3I Atlas is now roughly 300 million miles from Earth and is gradually fading. However, high-sensitivity telescopes can still collect spectra from its coma, the envelope of gas and dust, to determine how it evolves as solar heating diminishes. This phase is crucial. The comet's outbound trajectory and changing light curve will help researchers model its density, spin rate, and internal composition. The International Asteroid Warning Network's campaign, running from November 2025 through January 2026, aims to build the most complete data set yet on an interstellar body before it vanishes back into deep space. In the future, when the Vera Rubin Observatory begins full operations, it will scan the entire sky every few nights, with the potential to detect many more interstellar visitors. Astronomers predict that events like 3I Atlas could become an annual occurrence rather than a once-in-a-decade phenomenon. This would transform these fleeting encounters into a new field of research, the comparative study of interstellar comets. For now, 3I Atlas continues on its outbound path. Faint, but still measurable. Within months, it will slip beyond the reach of most telescopes, leaving behind terabytes of data. This data will offer a clearer picture of how systems in the Milky Way exchange matter across vast cosmic distances. 3I Atlas may be fading from view, but the scientific legacy it leaves behind will shape how we study interstellar visitors for years to come.